Okay, hello everyone. Welcome to this training session on the different data types that are supported in the xyzt.ai platform. And we will also mention and talk about the new data type, which is called movement path data today. My name is Bart. I'm one of the founders and CTO of xyzt.ai, and I will guide you through the different types of data supported in the platform. But first, I would like to ask you kindly a question to set the scene. And the question is, what kinds of data sets have you worked with? And it's a long list that I put up. It could have been even longer. But in this poll, the different questions are: one, traffic stats on road segments, traffic stats from traffic counters, raw floating data, vehicle data, road event data, public transit data, IoT sensor data, telco data, bicycle data, and people flow data. So please indicate the different options that you worked with before, not necessarily in the xyzt platform, but maybe also in other toolings. And of course, if you have data sets flying around or that you worked with that are not mentioned in this list, you can indicate other and just put it in the chat. Let's wait a few more seconds. Okay. And okay, it's good to see that many of you are using raw floating vehicle data. And some of you seem to have used also, interestingly, some bicycle data, which I think for city analysts is a really useful data source to map that type of modality. So having set the scene, the goal of this training today is to understand what different types of data sets are supported in the xyzt.ai platform. And commonality is, of course, that is spatial data. It's somewhere on Earth, somewhere on the map. But also many data sets are also temporal. I will also go into the different formats. So when you work with data like an Excel file or a CSV file, that is called a data format. And I will explain which formats are supported in the platform. And then we will also discuss how to connect your data sources to the platform. I will do this by the end of the training so that you understand all the different steps. And at the end of the training, I will do that for movement path data. And I will take a step in between also for geometry data. And then finally, I will briefly highlight the different use cases that are supported by the different dataset types, which are different for all the different dataset types. But it will guide you also into choosing which data to procure or to buy from a data provider. Let's start with an overview. So today I will discuss 5 different data types, and the first one is actually the first supported one in the platform. About 5 years ago, we started and we launched the platform with support for movement data. And movement data is basically a sequence of GPS traces. So imagine that you're driving a car, or you're driving a bicycle, or you're a captain on a boat, and your vehicle is being tracked. And typically then you have, at every 5 seconds or every minute, you have a GPS position together with some additional properties. And the sequence of these GPS positions with all those properties is called movement data in the xyzt platform. And there's many different data providers in different domains that provide this data. For instance, in maritime, there's Spire Maritime. And in the road and traffic, the land mobility, INRIX trip data is a data source like this. Second one I will discuss is point data. Point data is a bit of a special case for movement data. Instead of having traces of GPS points, you have individual GPS locations. For instance, there's an accident on the road, and you have at that specific location and timestamp, you have a data point that says there was an accident of this type, of this severity, for instance. It doesn't have to be accidents, luckily. It can also be other data. For instance, it can be data about where people go into the brakes with their car. And by combining all this data, you get a sense of where, for instance, there are blind spots in safety or where there are issues in the road quality and so on. Then I will move on to geometry data. And geometry data is a different data set type in the platform. And it's basically data sets where you have static shapes like points or lines or areas, polygons, and you have non-temporal properties associated to those shapes. For instance, OpenStreetMap provides road network data that is geometry data in the xyzt platform. But it doesn't have to be roads. It can also be areas or neighborhoods in a city. It can be countries. It can be locations of shops. It can be anything as long as the location is static and there's no temporal data associated to it. From geometry data, I will move on to a dataset type that is very closely related, and it extends on geometry data by adding temporal data to the static shapes. So think of it as having measurements or data records that are varying over time, but that are associated to static locations, static areas, static roads in the road network. And in the mobility and traffic domain, for instance, companies like Here and TomTom, many of the data sources that they provide fall into this category. Finally, I will move on to the latest child or the latest dataset type that we gave birth to in the platform. It's called movement path data. And it's data sets where you still have information about individual vehicles, but instead of having GPS traces or GPS locations, the movement of the vehicles is basically defined by a sequence of road segments followed. So for instance, a vehicle is first on the highway, then it takes ramp exit 51, then it gets on Main Street. So there's this whole sequence that you can encode in data of how a vehicle moves on the road network, and that is called movement path data. This type of data set is getting very popular in the mobility and traffic space, but it can also be useful when you have other predefined networks, like for instance, in maritime, you could have a network of typical routes that vessels take, and you could encode data onto that network. Let's start with movement data. This is an example. It's one of the sample projects in the platform. You see here on the lower left on the dashboard, you see a number of ships. Here also on the lower right, you see a number of ships. And movement data basically encodes the sequence of locations of those ships. And that you see here at the top, you see those sequences visualized as a density map. So basically, if you connect the dots, you get lines. And those lines we call trajectories in the platform. And this is how vehicles move, and you can visualize the patterns of movement and analyze the traffic flow in the maritime case in this case, but it also works for data on the road network. This is another example in the platform. It's a case where INRIX's floating vehicle data is showcased on the roads in Germany. And the use case is about analyzing traffic flow near a road closure. And so what you see here, you see basically the result of accumulating all those different GPS positions as a heat map to highlight where there's a lot of traffic in this example. So this is a very powerful dataset type, and it's one of the dataset types that is used most in the platform. So how does movement data look like? And the easiest way to represent that is by showing you a table of the different records or the different rows of the data. And you have to think of every row in the table as a single GPS location on the map, a single dot on the map. The xyzt platform expects this data as a CSV file or multiple CSV files, or as Parquet or multiple Parquet files. The difference between CSV and Parquet is in many places. CSV is, for instance, it's a text-based format. It's easy to read by a human, but there's no information about the data types. In Parquet, there's information about whether a certain property is a number or is a string property. So there's a little bit more information, but the platform accepts both, and the performance of getting data in is similar when using both. So what's expected to be in the data at least is an ID, an identifier of the vehicle. In the case of the maritime domain, it's typically the IMO number or the MMSI number. In the case of a floating vehicle data, road data, it's an anonymized unique ID for a trip or for a vehicle. Then you have a timestamp, you have a longitude, latitude, coordinate. So they are expected to be in separate columns. And then there can be any attribute. In this example, I put speed and heading, but it can be whatever attribute is in your data. So don't think of this as a prefix template that your data has to be in. The platform is adaptive to the properties in your data, but at least it should have movement data, should have those 4 first properties to identify a GPS point to a specific vehicle at a specific time, at a specific location. You will also see that multiple rows will have the same vehicle ID because, of course, you have this trace of GPS points. So it's not just one GPS point per vehicle, it's multiple GPS points per vehicle. So keep in mind, the vehicle ID is not the record ID. It's the ID of the asset, the vehicle, the ship, the car, the bicycle, whatever you're tracing, that it's associated to. So this is the first part of the data for movement data. The platform also allows you to upload what is called metadata. And meta is basically describing your vehicle. So it means that it's data that is constant in time. There's no timestamp associated with it. And it's data that is tied to the same vehicles that are mentioned in the data. So in this case, this 6549 and so on number is a car, and it's of the make Audi, for example. And again, here, the data properties can be anything. So they don't have to be enumerations like car, truck, and so on. They can be numbers as well. For instance, year of make could be a number that is constant. And the platform allows you to upload that separately. You don't have to. You can put this data also in this table and upload it with every record. For instance, if you buy data from Bridgestone, typically this is just repeated with every record and you can upload it like that. But you can see that because there's multiple rows for the same vehicle, you're sort of repeating the same content over and over if you would put the vehicle type in this data set. So you can put it as a separate table and upload it. Also, this is CSV or Parquet, one file, multiple files. CSV files can be gzipped before uploading. So that's movement data, and very closely related to movement data because it's typically a data set that comes from the same source, but is basically individual points from that data source, and therefore we called it point data. And point data, in the platform, there's a very nice example provided by Bridgestone Mobility Solutions, BMS, and it's data about locations where people go into the brakes with their car. They suddenly brake, or they take a corner, like a corner too quickly, which is an indication of a potential accident location. So, and if this happens a lot, you can see hotspots in the data, and it can mean that those locations where those hotspots are identified can be a potential location for improvement in signage or in road infrastructure. In this example, there's a little dashboard that was built using this data, and it highlights 2 intersections. and it highlights the distributions of events. So you see in these locations, there's a lot of break events, more so than cornering, which is taking this turn too quickly. And in these locations, it's the opposite. It's more cornering events than break events. You see there's also a trend line. So over time, you get to see, is it increasing or decreasing? And then you can make reports on whether things improved or whether things deteriorated. So what does point data look like? Using the same type of representation as with the movement data, we expect either CSV files or Parquet files in the platform, but the required properties in the data are a little bit different. First of all, timestamp, because the event, the point record has some temporal attribute. And also you need, of course, to know where those events happened. And then the other attributes or the other properties can be anything. In this case, I put in the example a type like a crash, harsh braking, a cornering, and then maybe the speed at the time that this event started. So for instance, a car crashes at the speed of 77 miles per hour, for instance, in Australia. So what is different here? No metadata, because typically it's just one event, and typically the metadata is put within this table. There's no identifier because it's not needed. There's no link to a vehicle needed anymore. If you want to have the link to a certain vehicle, you can put it just as a traditional property with the data. And the goal for this type of data set is really to do a statistical analysis. It's really meant to be used with lots of data, not when you have just a few points on the map. If you only have just a few points on the map, there's a different type of data that is more suitable. So think of this as when you have lots of data, you need to filter or qualify or quantify what is going on. And before going to the next data set, I have the second poll. So I've already talked about CSV. I've been talking about Parquet. Later on, I will also talk about GeoJSON and Shape. But maybe there are some other data formats that you would like to be supported in the platform. And I went through the whole Jira that we have with all the customer requests, and I took the ones that are most commonly there. And the first one is WKB. It's an acronym for well-known binary, well-known text. Very common when you store geometric data in a database, and then you extract the data into a CSV file. So sometimes people use that. GeoParquet is an extension to Parquet, which has become increasingly popular. I haven't talked yet about GeoJSON, but GeoJSON with temporal data embedded in the GeoJSON is not yet supported. So that's another question there. NetCDF, not sure people use it in our customer base. We've had a few requests around that. GPX, KML, maybe if you use some biking apps or some routing apps for hiking, very popular formats for GPS traces as well. Less so in the commercial mobility and traffic domain, and then maybe other data formats. So please indicate what you would like maybe to be added, and then we can take that into account. I'll leave it open for a couple more seconds. And okay, there we go. Okay, I see some requests for WKB and also for GeoJSON with temporal data, which is quite interesting because it brings me to the next topic, geometry data. So geometry data, from the two previous data set types, we were using mostly GPS coordinates. It doesn't have to come from GPS. We have customers using radar blips. We have customers using Bluetooth location data, which is not from GPS. But most of the time, the data sets that we see for movement data and events data is from GPS. Now I will move on to geometry data, and it is a different thing. So I would like to explain what geometry data is, and I will also show you how to get it into the platform, because it gives you an idea of how to configure the platform for dataset types. So geometry data is different in the sense that it's broader. It's not just GPS locations, it's not just longitude, latitude points. It also allows for line segments or linear features, and also for polygon features, which are, you can think of areas on a map. And we support the two most popular data formats, which are GeoJSON and Shape. And the example that you see here is from GeoJSON. So it's a text-based format. It's very easy to understand. It's a key value format. It's standardized, so it follows a prescribed way of structuring your data. But at the same time, it's very flexible in having your custom properties in there. So what the example that you see here is, for instance, from an OpenStreetMap dataset. So you have road segments that are basically defining the road network. And I just highlight one single road feature here, and you see the 3 dots, so there can be many, many more. And typically there's millions and millions of more. So you see it's the type is called a feature, so that's a standardized way. And you see the different properties in this data. And in this case, there's a property ID, name, road class, and speed limit. Those properties are not prescribed, so you're free to choose which properties you have in your data, and the platform adapts to your data. So in this case, it's a road segment. It's the name of the road is called Oak Street. It's a residential road, and the speed limit is 25 miles per hour, for instance. The next part is the geometry, and that is standardized. So there's no freedom in changing what the keys are. Of course, you can have different locations or different parts on Earth or different areas on Earth that you put in the data. So geometry data is just this. It's just files with GeoJSON or shapefile. It's points, lines, or polygons. And keep in mind, it relates to the poll that I had. For geometry data, this has to be non-temporal. Of course, if you want, you can put a timestamp in. For instance, like the speed limit is 25, and then you put another field like since, and then you put a timestamp here. For instance, the construction of the road was done then, or the speed limit was set at that time. That is possible, but you cannot put like a sequence of time series into a geometry data set. There's no metadata like with the movement data, so no separate files to define constant properties. All the properties are expected to be in the GeoJSON or the shapefile. So let me show you how to get this data into the platform. And there's two options. You work with GeoJSON or you work with Shape. If you have a different format, there's many, many ways to convert between formats. And what I typically do is I ask ChatGPT to give me a one-line, command line command to convert between format A to GeoJSON, for instance. And then you have a one-liner that you just copy paste, and very easy to convert. We expect GeoJSON, one or more files. The GeoJSONs can be zipped with gzip, which is a very popular compression format for individual files. And shape files, if you're familiar with them, a shapefile is a bad name. It comes as 5 files, basically. So we expect them in a zip file. And you can put multiple shape files in one zip file if you want. So let me show you how that works in the platform. So I'm going to log into my demo account. I have a number of data sets here. For this, I'm just going to create a new project. I call it training dataset types geometry. I leave it to the default time zone, which for this data set is not super relevant because there's no time in the data. And then I click here on data sets and I create a new data set. So here in the top right corner, I give it a name. For instance, I call it roads. And I think the area is going to be Portland that I'm going to be using. And here in the drop-down box, you see those 5 different dataset types that I was talking about. So this is what I select, geometry data. I select the format. The reason I have to select it beforehand is that the platform is very adaptive to the type of data that you are working with, and it will provide a wizard. And for GeoJSON and shape, the wizard is a little bit different. So that's why we ask you to define which format you're going to be using. You have to describe what's in the data. In this case, it's not trips, it's road segments. So let me just call it segments. And this is just so that the platform understands what's in the data. And when it shows you something in the UI or in a visual, it talks about road segments and it doesn't talk about air quality sensors, for instance. I hit create dataset. And by doing so, I have done the first step. I have defined the general settings, which are the name, what's in the data, and so on. The second step is to define what are those different properties in the data. And this is typically the step, the first time that people do it takes a little bit time to configure it correctly, but we help you in many, many ways. And the easiest to configure and to tell the platform what's in your data is to give a sample of your data to the platform. And that's what I'll be doing here. I will be just dropping a file on this Dropbox from my training data set. So I'm going to go into the geometry ones, and I have my roads here as compressed GeoJSON, and you see it's 5.8 megabytes. So uncompressed, it will be probably be around 50-60 megabytes of data. So it's a few roads, not so many, but it's like city level number of roads. What you see now is that the platform auto detects the different columns in the data or the different properties in the case of GeoJSON, and it detected a priority level, a segment ID, a road class, a name, and a reverse ID. And in this case, I know that the segment ID is actually what uniquely identifies a segment. So I'm going to use this as the identifier. Remember also with movement data, you needed an identifier of which vehicle the GPS traces are from. In this case, you need an identifier that identifies which road segment we're talking about. And then all the other properties are basically optional, but I'm going to use them for good reasons. So I'm going to all use them, and they're optional in the platform. It's called custom. So I just choose custom for all of them. If I don't indicate anything, the property will not be available in the platform once you start uploading data. So if I don't set it to custom, the street name, for instance, will not become visible in the platform. And sometimes we see that users have data sets with 50, 60, 70 properties, and then it makes sense to just pick the ones that you or your customers will be using. The reverse ID is interesting. The reverse ID, you see, it has a minus sign and it has a similar format as the ID. And this basically means that for this road segment, there is another road segment in the opposite direction. And the ID is like this, with a minus sign in this case, but it can be a different way of representing. So this means that we support two-way roads, and I'll show you in the visualization later that it's nicely covered. The reason that these data sets are in my training sample is, of course, because there's a purpose to it, and I will go over each of them individually. In the platform, you can configure many more things about your data format. For instance, if you have no data values, if you have a minimum and a maximum expected value, you can configure all of that. You can add a description to your data. So for instance, if you want to know that your users of your data set understand what this is, you can provide a description. But in this case, what is important is that you can assign special meanings to certain properties in your data. And in this case, we allow you to set a priority level to a geometry dataset feature. And it means that if you zoom out, we will not show the less priority features. And if you zoom in, we will increasingly show the higher priority, the lower priority features as well. And that is very useful if you work with road networks with millions and millions of roads in a country. It doesn't make sense to try to visualize all the roads when you're looking at the entire country. You typically only want to visualize the highways. And that's what this feature is meant for. The same with the name is a special meaning, because if you look at the example here, you see the segment IDs, they don't really have a meaning to it. They're just an internal unique ID to be able to distinguish between different segments. So I'm going to assign a special meaning to the name of the road, and I'm going to call it a display name. Very common in user interfaces. You want to visualize a human readable name, and you don't want to visualize the internal unique identifier. So that's what I'm going to do with the name. And then the reverse ID is also a special one. It's also mentioned reverse ID in our platform, so a little bit of a coincidence here. It basically means that the platform understands that this property is actually the property that identifies the reverse direction from this one. And it means that the platform knows that those two road segments are actually the same road, but in the opposite direction. So once having done that, I can save that. And once you saved, you will see a tabular representation of your configuration. And then the final step is just to drop the files to your platform. In my training sample, I only have one file, so I'll just drop it again here. And you will see now this file is queued for processing. What does that mean? It means that it's not immediately processed. And the reason we don't immediately process is that the typical data sets that people upload to our platform, they're in the order of 250 million to a billion data points. So it's typically a lot of data. So the platform, what it does in the cloud, it allocates a dedicated machine to process the data. And when there's no machine running, it takes a few seconds or sometimes minutes to fire up the machine and process the data. In this case, it's a small data set, so it could have been done just on the machine, on the server itself, or where we are now connecting to. But in general, it just launches a machine that is capable of handling billions and billions of data points. So while we are waiting for processing, I'll further configure my project. So I go to my active project, I see there's one data set. I'm also gonna attach a background layer. So for that, let me just take one from the samples. So what I'll do is I'll take this satellite and labels background layer. So this is just to provide a map behind. If I want to use another one, I can just detach this one and attach another one. So you're very flexible in doing so. If you want to follow up on the processing progress, because some of the processing jobs, they will take a couple of minutes, some of them will take a couple of hours, depending on the size of the data. You can always go back to your dataset card. So on the dataset card, you see the status. Is it queued? Is it processing? Is it ready? If you click on the dataset card, you will see at the top what's the general progress. Like if you install an update on Windows, you see like it's 50%, 70%. You can follow that here. And if you have multiple files, you can follow the progress as well in this area. So you can see for all the different files, are they queued still? Are they processed? And if there are issues with the processing, there is a log file. You click on it and you will see that issues are logged in to a log file that you can also download and inspect. So here it logs warnings, so there are no errors. So it just logs warnings that certain features, for instance, don't have a reverse ID, which is quite logical because some of the roads, they are one way. Think of a highway system where the road segments are one way. So once it's done, you can start using it in your analysis. you open the page, for instance, the visual analytics page, and you would see your data set. And by default, the platform fits on the data, and it will take, for geometry data, it will take one of the first properties, and in fact, it chooses the first numeric property. So in this case, priority level is a numeric property. It's 1, 2, 3, 4, 5. It picks that property and it colors by some default color map based on that property. A couple things you will notice now, it's not painting all the roads. If you look here at the priority level, it's only 3 types. If I would zoom in on the data, you will see that many more roads become visible. So that's where the priority level kicks in, and it doesn't overload you with too much data. You will also see that some of the roads, they have 2 arrows, some of the roads have just 1 arrow, and that means that they are one-way or two-way. And data can live on one part of the road, and that will be important later on when we talk about speed and traffic on those road segments. The geometry data by itself is not extremely useful, but for some data providers, it is the way that data is provided. For instance, imagine you are providing or getting a data set with road segments, and you have some indication of the road surface quality for every road segment. Then you can plot the road quality as a color map, and you can start filtering and trying to figure out which roads have the poorest road quality. So it's spatial data, but not temporal data. In this case, I'm just coloring the reverse ID with a random color, and you see that the ones that are white, they don't have a reverse ID, so those are the one-way roads. If you are in London or in Australia or any of the other countries where people drive on the left side of the road, you can configure that as well. You go back to your data sets, you can go to the general settings, and you choose traffic side. So here you can put it to the left side of the road. So this is how you get geometry data in, and that brings me back to my training. It brings me to the next dataset type, which is time series data. And time series data is very closely related to geometry data. It just adds a temporal dimension to the data. And a typical example in the traffic and mobility area is when you work with aggregated floating vehicle data. And you have to imagine that you have a road network, and for every road segment, for a period of time, you have at fixed intervals. In the platform, it doesn't have to be fixed, but most of the data providers, they use fixed intervals. You have every 5 minutes, every 15 minutes, you have, for instance, the average speed, the number of vehicles on that road segment. So it's time series, but it's huge time series. So you have a time series for every segment on the road network. And here in this example, we visualize such a data set, and we color code the average speed over an entire time period that you can see selected here at the bottom for every road segment. Extremely useful data source. It's not just for road segments, it's also being used for air quality sensors, for traffic counters, for parking occupancy, anything that has a spatial location and that has properties that change over time. So the first part of the data is exactly the same as with geometry data. It's just the static locations, areas, line segments that have temporal attributes. The second part of the data is very closely related again to what we used before in the point data or the movement data. So it is data that sort of ties back to the features in the geometries, and that adds this temporal dimension. And the platform expects for that CSV or Parquet files. So it expects, if you work with CSV, columns like geometry ID, timestamp, average speed, number of vehicles. And again, those are customizable, but at least you need to have a timestamp, and at least you need to have a geometry ID. And this identifier points basically to your geometry data. So this is why the platform knows that this measurement at noon on the 11th with an average speed of 123 ties back to road 001. And basically that's it. I'm not going to show the data upload for this one because it's very similar, but that's how it works. And then that brings me to the final data set. And for this, I will show the upload again. So just to iterate on how that works. And it's a very exciting data set format that we have in the platform. It's called movement path data. And movement path data, one of the data providers that we work with a lot is Inrix from the US. And they provide this type of data as a very powerful data source. And we will discuss that in the use cases. So you see there's a road network in this case. In general, it doesn't have to be roads, but in practice, most of the time it's a road network. But then also, you don't just have measurements on those road segments, you actually have trips of vehicles driving through that road network. And it allows you to do a lot of traffic flow and origin destination type of analysis. And we'll talk about that. Movement path data is probably the most complex to get in the platform, but we try to get it to make it as easy as possible. And I will try to show that to you later on. So movement path data basically depends on a geometry data set. So imagine that you created a geometry data set with the road network in your city or your country. And once you've done that, you can just use that data set as the base of the road network. And then it expects CSV files or Parquet files that we call data files. And what you see here is some of the things that we've seen before mixed together. You see things of the movement dataset type, and you will see things of the geometry, of the time series dataset type. Sorry about that. So first, movement data had a vehicle ID. And again, here we have trips of vehicles, movements of vehicles along the road network. So we need to know which vehicle it is. Of course, everything anonymized according to GDPR and the other privacy regulations. And you see that there will be multiple rows belonging to the same vehicle. Next is a timestamp because vehicles move through time. So this timestamp basically tells the platform that this vehicle was at this road segment at this time instance. So you see, very similar to movement data, but instead of using a GPS location, we use a reference to the geometry dataset. So think of this as a foreign key for people that use SQL. Think of this as a key that is pointing to the feature in the geometry data. So this replaces the GPS location in movement data. And then again, any attribute that you want to associate with your vehicle. So in this case, we just associate the speed that the vehicle was driving on average, or maybe maximum, minimum, mean, median speed, when the vehicle was on this road segment. In this example, you see the same vehicle in the next 5 minutes moved to a different road and was driving with a slightly lower speed. So this is how you see that it's like a sequence of road segments followed with all this information. In practice, this is big data. This is a lot of data because it's representing every vehicle on every road segment in the network through an extended period of time. So it can be a day, a week, a month, whatever you have in your data. So you see the vehicle ID, very similar to movement data, the geometry ID, very similar to time series data. And then finally, I talked about referencing the shape in the geometry dataset. Finally, you can upload metadata, which is exactly the same as with movement data. So it's the data that is unique to a vehicle, but doesn't change over time. So in this case, you need a vehicle ID, pointing back to which vehicle it is, and then you can have any attribute on the road network. So before going into the use cases, I want to take a couple more minutes to show you how that is done. So for that, I'm going to create another project. So training dataset types, and I'm going to show you movement part data. For that, I'm going to create, similar to before, create a new dataset. And I choose movement part data as a type. I give it a name. So for example, trips to Portland. And I'm gonna tell the platform, in this case, this data set captures trips. It doesn't capture road segments. It's really about trips on the road network. I will still be using CSV. So I create a data set. And you see the first step after doing these general properties is selecting the geometry data set. So for that, there's a selection box. It shows you all the geometry data sets that I have in my platform. It shows you the last one created at the top. So that makes it easy to know which one it was. And once you've selected that, you can move on to the next phase. And this should be very familiar. You see, I need at least a vehicle identifier. I at least need a geometry identifier. And I at least need a timestamp. So if I go back to my table that I used before, you see vehicle identifier or the identifier, timestamp, and geometry identifier. And then I can have custom properties. Again, I can drop a file onto here to see all the different properties in the data, configure them, save what I configured. In this case, I'm just going to reuse what I configured already beforehand, so I can upload that configuration. I'll show you what that configuration looks like. It's actually also a CSV file. So let me just open that in a text editor so I can show you that. It basically has one line for every property, and it just contains a certain syntax of what which property means. For instance, in this file, the 5th column is actually the geometry ID. So I'm going to use that file to skip the process of configuring everything manually. And once you've uploaded the file, you will see the table below. Or if you go back to the wizard, you will see how the wizard is configured. So for instance, you see that the identifier is in the 1st column and the geometry identifier is in the 5th column. There's also speed and vehicle type in this dataset. Once you've done that, you can try the validator. The validator is basically meant just to try to see that the data files that you have match the format that you specified here. I'm not going to use that now. I'm just going to upload the file that I have, and it's a little bit big. It's like 390 megabytes compressed. So if you would uncompress it, it will be about, I would guess, around 2-3 gigabytes of data. So I'll just upload it. You'll see it will take a little bit of time to upload. And that's why we prefer people to gzip the file, because it's faster to upload. We're not going to wait for this. I'm going to move on to the use cases, but while it's uploading and while it's processing, we can come back to this data set at the end of the training session. Let me maybe already, just for the sake of not forgetting it later, attach a data set to the platform, and we can monitor the upload here and the processing here later on as well. So that's movement part data, and movement part data is extremely powerful. It's one of the most powerful data sets when you work with road floating vehicle data. And the reason is that you have access to every individual vehicle, where it comes from, where it goes to, where it was driving, and all the different speeds. And that brings me to the use cases. So depending on the data set type that you have, there will be different use cases that are supported. And it really depends on what you want to do. And you have to be careful when you talk to data providers that you understand the type of data that they will sell to you. Because if it's just aggregated data on the road segments, traffic volume, speeds, time series data in the xyzt platform, you will not be able to analyze where people come from and where people go to. So different use cases. So first of all, movement data, it's as powerful as movement path data, the last one that I was just showing. You can do traffic flow analysis. So you can analyze diversions. You can set filters like where does traffic come from, where does traffic go to. You can see trends over time because there's temporal data. You can do origin destination analysis, dwell time, wait time, travel time, everything possible. Even with the GPS data, you can go in and look at individual lanes on the highway, for instance, and see that the left lane is never congested, the middle lane is sometimes congested, and the right lane is always congested because the trucks are waiting or something like that. So it's extremely powerful data source that gives you a lot of flexibility to filter out the data and do all those types of analytics. Point data, most of the use cases, road safety, road maintenance, road quality, hotspot analysis, trend analysis. It's really meant to find the areas, the locations in space and time where certain things happen a lot. So the typical example is Bridgestone ABC data, but it can also be traffic accident data that is, for instance, in the US, public data that you can just download and use in our platform. Geometry data, it captures basically all traditional GIS use cases. So all the data that you would use in an ESRI platform, like ArcGIS or an open source tool like QGIS, that's the type of data that would fall under geometry data. Data that typically doesn't have a temporal attribute. It's just points, lines, polygons, and the platform supports lots of data for that as well. In the examples that I gave, I was using road segment data, and typically we see that being used together with temporal data. For instance, if you buy data from here or TomTom, or you access the TomTom platform to extract a route, or that's typically time series data. Typically, you would have a geometry, certain route or a certain set of roads, and you would have temporal instances of measurements, or maybe aggregate measurements, like every 5 minutes of the day, every 15 minutes of the day, you know for that road segment, there are so many vehicles, and this was the average speed, the 85 percentile speed. So that's time series data. Important, there's no traffic flow information anymore in the data. You don't know that those 51 vehicles on Main Street at 5 p.m. in the afternoon, you don't know where they come from. So that's important to realize. So you're not able then to analyze traffic flow. I've talked a lot about mobility and traffic, but it can be traffic counting data, it can be sensor data, it can be anything like telco data, typically time series data. And then movement path data, talked about that, very powerful, almost as powerful as the movement data, the first type of data. The main difference is that it's tied to the road network. So on a road segment, you cannot make a distinction anymore between the left lane, the right lane, the beginning and the end of the road. So that's important to realize. On the other hand, because it's on the road network, you can use the road network for your analysis. And that's what was showed in that example. And let me go back to that example. Here in this example, the user selected a true filter on this exit on the highway just to analyze what percentage of traffic flows back onto the highway. And just by color coding, you immediately see a lot of traffic goes back onto the highway, even 40% of the traffic that comes on this segment. So you can do traffic flow analysis, but you can also do it using the road network traffic and mobility analysis use cases. So before going back to the data set that we just created, you can try for yourself. And I know we took a lot of time today because it was a lot of material to cover. But the best way to learn and to experience is by just following one of the tutorials. So just go to the Docs platform, click on tutorials. At the top of the page, you have a drop-down box. Pick the tutorial that is of interest and just follow it step by step. And you will be able to see what you do. You will be able to see what you do is correct. So there's always reference images and so on. And every tutorial comes with a sample data set that you can just download and use while doing the upload like I did. So let's have a quick look at our data set. So you see it has been processed in the meantime. So around 6 minutes ago, it was processed. You see there's about 24 million records. What's a record? It's just one piece of a trip. So one row in that table that we were talking about. So if I go to my active project, I see my data set is there, my background layer is there, and I can click on it. So again, it fits on the data. The first time you load the data, it can take a few seconds because it's loading some of the tables, some of the information in memory so that you can analyze very quickly. And in this case, it shows you number of trips. So by default, it just picks a color map. In this case, this one. If you want a different one, you can change it to a different one. And it color codes by number of trips. So it means that the platform is on the fly counting how many trips there are on a certain road segment. So in this case here, you see like there's 4,619 trips on this road segment. And that's about 5% of the whole data set. And then if you want to see only what is happening, and I can just do that by right-clicking. If you want to see only what is happening, traffic passing through that road segment, where does it come from, where does it go to, you can set a true filter. And from the color map, and I can make it a little bit more bright, like this, by just moving my knob to the left. You can start to see where traffic comes from, goes to, through this area. So it's very powerful. It's not just traffic volumes on road segments, it's really millions and millions of trips through the different roads that you can fully analyze using the analytics that I'm showing with those different types of filters. And you see how it's supporting two-way traffic on the same road segment. So I know I took a lot of time, almost an hour. You can skip the parts that you don't need. You don't need to go through all the tutorials, but at least now you know the different types of data that are supported. And this is also one of the main reasons why people use our platform. It's not tied to one specific data set. It's not tied to one specific data provider. It caters to all the different use cases that we see in the mobility and traffic space. Today, I showed you how to use the UI, how to use the web application to click and to upload files. In the next training, which is just after the summer holiday break for us in September, I will show you how to do exactly that with the API. This will be a training that's not for everyone. If you're familiar to using coding, scripting, if you use Python, if you use TypeScript or any other coding language, and you're interested to learn how to use the API, to use scripts and automation to get data in, that's the training for you. It will go further than just data uploads. We will also show you how to use the API for dashboard creation and for queries. So join me in that training as well if you're a little bit more technical. And otherwise, I will see you in the next training after September 3rd. So thanks for listening in. Really enjoyed preparing for this training, and I'm really looking forward to what different data sets you will be providing and uploading into the platform. Thank you.